Good morning. Today we are going to talk about array concepts in R programming. I am Dr. Anusha, Department of Information Technology, M.O.P. Vaishnav College for Women. So R, as all of us know, it is an open source software which is mainly used for statistical computing and graphical presentation to analyze and visualize data. So R is actually an open source software. So it is available, it is suitable to work on Linux platform, Mac and Windows. So you can download this R open software from CRAN. CRAN stands for Comprehensive Archive Network. So before going into R arrays, we just have a brief intro about R objects. So what is an R object? In any programming language, we talk about variables and data types. In R programming language, we specify or we associate data types with objects. So basically in R, we have different types of objects. So arrays, list, matrices, vectors, data frames and factors are the basic objects in R. Now today's session we are going to focus only on array object in R. So what is an array in R? Array, as everybody knows, the basic definition is it is a data structure that can hold multi-dimensional data. Multi-dimensional data means what? More than one dimension. It can be any number of rows and columns. So arrays can have any number of dimensions in R. So what is then a keyword you specify for creating the dimension is dim. Dim is used for creating the required number of dimensions in R. So how do we create an array? What is the syntax for creation of arrays? So you have to give array underscore name. It's a variable where you store the array. Array underscore name is equal to array of open brackets. It takes, this array function takes two parameters. The first parameter is the data and the second parameter is dim. As I already told you, dim is for specifying the number of dimensions in R. First one is data. Data is the content, the input vector to the array. Dimension, so dimension again takes three parameters. The first parameter is row size, column size and the dimension names. Row size is how many rows you want to have in your array. Column size is how many columns you want to have in your array. And dimension names. You want to give a name for your dimension. You want to name a row or a column in your R array. You specify in the form of dimension names. So first is the data, an input vector which is given to an array. Row size, number of elements the array can hold in a row. Column size is the number of elements in the column, and dimension name is used to change the default names of the R array. So what are all the operations that you can perform in array? First, before going into the operation, you need to create an array. So first one, it's in a cyclic fashion. Create array, then you have to name column and row. Then you can do accessing of arrays. That is, you should be able to access the array elements, whatever you have created, followed by array manipulation and calculation. So these are all the basic operations in an array. Now let us discuss about each and every of the operations. So now let us start with creation of arrays. How do we create an array? As I already told you, it is a two-step process. Array creation is a two-step process. You need to specify a vector and an array function to create an array. So step one is you have to give the data, that is a vector. Second one is use an array function. So create two vectors of different lengths. In this example, we are going to have two vectors of different lengths, need not be of the same length. The array vectors can be of two different lengths. For the second step is, okay, the first step will create a vector. Once you create a vector, you use these vectors as an input to the array function which has been already defined in the syntax. So this is a two-step process which we are going to apply for the array creation. So now let us look at an example following the syntax. So hash represents the comment statement. So it will not be executed. It is just for your understanding. Hash stands for the comments. Okay. So first comment says create two vectors of different lengths. We are going to take two vectors for array creation. So how do we denote vector? First one is vec1. You can give any variable name or any user defined name, need not be vector1, vector2. vc1, that is vec1 is equal to C of 1, 3, 5. So what and all data I have in the first vector is 1, 3, 5 or the three elements that are present in the first vector. And the second vector what I am going to take is vec2 is equal to C of 10, 11, 12, 13, 14 and 15. As you can see from the slide, the two vectors are not of the same length. Vector 1 is having 3 and vector 2 is having 6 elements respectively. Now we have to give these vectors as an input to the array function, what is defined in the syntax. So array name I am just going to store in the variable called result or res. I am just naming the variable as res is equal to array of array function. What is the vector we are going to pass? C of vector 1 comma vector 2. First two vectors we are passing, comma, dimension. What is the dimension attribute? It is used to specify the row and the column of the array in R. 3 comma 3 comma 2. So the array dimension is going to be having 3 rows and 3 columns and 2 arrays. Okay. So that is how we are going to create. And then after creating the array, we are using the print statement to print the contents of the array. Print res, which will print the contents of array. So the output will be like this. So we had the first one as, you can see 1, 3, 5. So that will be printed as the first column, 10, 11, 12 as the second column, 13, 14, 15 as the third column. You can see here 10, 11, 12 will be the second column, 13, 14, 15 will be the third column, 1, 3, 5 will be the first column. So that is the output of this particular array creation. Since we have given dim of 3, 3, 2, we are getting two arrays. So first one and the second one having the same elements, which is created using vectors of different lengths. So now the next operation is how to create or how to name a row and a column. How are we going to name a row and a column? So default, so again we'll start from the scratch. We will create an array first. How do we create an array? By using two vectors. So first one is vector 1 is equal to C of 1, 3, 5. Just for understanding purpose, we are taking the same example. Vector 2 is equal to C of 10, 11, 12, 13, 14 and 15. These are the two input vectors to the array function. So now we are going to give a name for row and column and the matrix whatever we are going to derive from this. How are we going to do that? So here we have to introduce three variables for naming the column, row and the matrix. So what are the variable names we are going to use here is row underscore name, column underscore name and matrix underscore name. So in row underscore name, how many rows we are going to have? 3 rows. So we are giving us C of row 1, row 2, row 3. And in column names, we are going to have 3 columns because it's a 3 by 3 array. So we are going to have 3 columns and 3 columns have to be named as column 1, column 2 and column 3. Please observe we have given double quotes because they are all names whatever we are going to give. So it need not be call 1, call 2, call 3. You can give your own name but it should be meaningful. Call 1, call 2 and call 3 and row names and the matrix names are C of matrix 1, matrix 2 because we are going to print 2 arrays out of these vectors which is given as an input for the array function. So now we are going to take these vectors as input to the array. So in the previous example, we just gave the vector alone, dimensions parameter, we didn't apply at all. That is the naming of rows and columns, we didn't apply. Now we are going to apply the names here. So how are we going to apply here is, result is equal to, the first parameter is array. Array is equal to C of vector 1, vector 2, dimension. Now dimension, we are not stopping with C of 3, 3, 2. So we are going to incorporate or give name for the row and the column. So what we are going to give here is dim names is equal to list of, what is the first row name? Row underscore name, call underscore names, matrix underscore names. Already we have saved the name for row underscore names as row 1, row 2 and row 3. So that will be substituted there. Similarly for column names we have given as call 1, call 2 and call 3. And for the matrix names we have given as matrix 1 and matrix 3. So now when we print the result, what happens here is the output will be like, instead of 1, 2, 3, what we already discussed, the first array is printed as matrix 1. Okay. So we have given as matrix 1. So matrix 1, after that call 1, call 2, call 3, row 1, row 2, row 3 are the respective column names and the row names whatever we have given. So now you can see all the column names and the row names are fully replaced by the names whatever we have used in the dim names statement. So now one more example for naming the rows and columns we will just analyze here. We are having two vectors A1 and A2. A1 is having 1, 2, 3, 4 as an element and A2 is having 5, 6, 7, 8, 9. Both the vectors are of different lengths. So now we are going to have row names as R dot names is equal to C of R1, R2, R3. In the previous example, we had row 1, row 2, row 3. Just for one more understanding, one more example I have mentioned here. And similarly, column names, C dot names is equal to C of C1, C2 and C3. Matrix name is C of first. That is, I am going to give the matrix name as first for the first matrix. So now we are going to create an array. So ARR is array name. Array function is going to take the vectors as an input, C of A1, A2. So all these 1, 2, 3, 4, 5, 6, 7, 8, 9 will come. Dimension is equal to C of 3, 3, 1. 3 by 3. 3 rows, 3 columns and 1 matrix we are going to have out of this array. And then dimension names, dim names, list of C dot names, R dot names, M dot names. So you are giving a list of names for row, column and the matrix. So C dot names will be substituted by C1, C2, C3. R dot name will be substituted as R1, R2, R3 and the matrix name will be first. So when you print the array, what happens here is it will be creating the matrix name as first and you can see here row 1, column 1 are named as R1, R2, R3, C1, C2 and C3. So now, okay, so far we have discussed how to create an array. Now we need to create an array as well as to access it. So how do we access the array element? So we use a method called indexing method, just like the same method what we use in other programming languages in R to access the array elements. So when you go to the previous example, I have an element called 7. In the first row and the third column. You want to access this particular number 7. How are you going to use the indexing method? If you can observe, 7 is the first row and the third column element. Now, how I am going to do here is array name, open square bracket and close square bracket. So, first row 1, third column 3, 1 from the first matrix. If I have two matrices, I have to specify from which matrix I have to extract the number from. So ARR of 1, first row, 3, third column and the first matrix, ARR of 1, 3, 1. Okay, so now if you take the previous example here, I want to extract 1 from here. Where is 1 located? 1 is located in first row and first column. So how do we have to extract this by using the index method? ARR of 1, 1, 1. First row, first column and the first matrix. So this is how indexing method is used for accessing a specific element in a specific row and a column in a matrix. Now you want to access, sometimes you may be interested in accessing a range of value from the array. So in that case, you need to specify the range by means of a special method. Say for example, the array name is ARR 1, 2, 1, 2, 1. So first row, 2 columns. That is, in the first row, I want to extract 2. In the second row, I have to extract 2 from the first matrix. So if I give 1:2, 1:2, 1. So what all elements are extracted here is 1, 4, 2 and 5. That is 1 to 2, 1 to 2. Everything will be extracted here. So this is about accessing a specific range of values from array. When you want to access the entire array, you can just specify ARR of 1. So if you don't specify any row or column ID, it will print the entire array as a result. This is how you access the entire array. Now next one is array manipulation. So we have learned now how to access the array. Now we need to look upon how to manipulate the array. So here again for array manipulation we need an array. That's the first step, right? So we have vector 1 is equal to, we are taking the same example, the elements having 1, 3, 5, vector 2, 10 to 15 we have taken. Now you have to give these two vectors as an input for the array. So result 1 is equal to array of C, vector 1, vector 2. What is the dimension? 3 by 3 array with 2 matrices we are going to print. So when you print RES1, the first array, what and all values will be having? 1, 3, 5, 10, 11, 12, 13, 14 and 15 as the first array. Now, we are creating one more array. We are having one more array means, so we need to have two more vectors, VEC1 and VEC2. There we have a totally different set of elements. 8, 4, 7, that is the first vector. And the second vector has 16, 73, 48, 46, 36 and 73. Now we are going to create one more array using these two vectors. So RES2, the first array is named as RES1 and the second array is named as RES2. RES2 is equal to array of C, vector 1, vector 2, dimension 3, 3, 2, 3 by 3 array with 2 matrices, and we are going to print the result. So now we have created the array. Now we need to create the matrix from this arrays. So the matrices are named as mat1 and mat2. So mat1 is equal to, from the first array we are accessing all the elements. So RES1, 2. So there is the entire row and the column is accessed. Similarly, matrix 2 we are extracting from the second array RES2. So matrix 1 will have the elements of the first array and the matrix 2 will also have the elements of the second array, and we are doing a manipulation in an array by using an addition operation. So we are going to add the first matrix and the second matrix and store the result in result 3, and we are going to print result 3. Now let us look at the output of this. So the first one we have 1, 3, 5. If you observe this previous slide, 1, 3, 5, 10, 11, 12, 13, 14, 15 will be the first array. It will be printed twice because we are going to create 2 matrices out of it. And the second one, we are going to have 8, 4, 7, 16, 73, 48, 46, 36 and 73. That is what we have here. We can see in the screen itself. So array 1, RES1 and RES2 we have seen. RES3 is the result of these 2. So you try to add the row wise. 1 of RES1 and the first row, first column, 8 is there. So 1 plus 8 will be 9. So what is there in the first row and second column of RES1? 10. First row and second column of RES2 is 16. So 10 plus 16, 26. Similarly, first row, third column of RES1 is 13. First row and third column of RES2 is 46. 13 plus 46, 59. So similar operation you have to do across all the rows, and you end up in getting a new matrix 9, 26, 59, 7, 84, 50, 12, 60 and 88. This is how we can manipulate an array. The last function what we are going to see in array is a very important function called as an apply function. What is an apply function is, when you want to do specific calculations across array, you go for apply function, which is a built-in function. So as the name implies, when you have a function, you definitely have to create parameters for the function. So I need to specify the parameters for the apply function. Apply of 3 parameters I am specifying. X, margin, fun. What is X? X is the array in which you want to do the calculation. Margin is nothing but the name of the data set you are going to use, and the fun is for function what you are going to apply. Sum operation, whatever operation you want to specify on that array element, that is specified by the fun operator. So margin can be having a value of C of 1 or C of 2. C of 1 means first dimension, row wise sum. C of 2 means second dimension, column wise sum. Now let us look at this example to understand the apply function in a better manner. First, we need to have an array for apply function. So C1 of 1, 3, 5, vector 2 is equal to, again the same elements I am taking so that you can understand it better. 10, 11, 12, 13, 14, 15. So now we have 2 vectors of 2 different lengths. We are going to give this as an input for an array. Array is equal to, that is res1, RES1 is the name of the array, is equal to array of 2 vectors we are taking, C of vector 1, vector 2. What is the dimension? 3, 3, 2. 3 by 3 matrix with 2 matrices we are going to print from this array. Okay, so now we are printing the array as such, print RES1. Now we are going to use the apply function to apply a specific calculation across this particular array, what we have created and stored in RES1. Print RES1 will print the array without any apply function. Now we will apply the apply function. Result is equal to apply of, what is the name of the array where you want to apply? RES1. So that is the name of the data set, comma, what is the second parameter? C of 1. C of 1 stands for row wise summation, comma, sum. C of 2 if I give, it is column wise. C1 means row wise. Name of the function is sum. So I am going to sum the row of this particular array, whatever has been created out of it. Now I am going to print the result. Let us see. So the first output is what? The output as per this one is, the array is 1, 3, 5, 10, 11, 12, 13, 14, 15, twice. 2 arrays we are printing. So now, when you are going to give the apply function, it is the row-wise summing. So row-wise summing means what? First row is what? 1, 10, 13. So add 1, 10 and 13. So 1 plus 10 plus 13. That is 11 plus 13 is 24. You add the first row of the second array. 1 plus 10 plus 13, 24. So first row sum is 24 and the second row sum is 24. As a result of this, the entire sum happens to be 48. Similarly, take the second row, 3, 11, 14. 3 plus 11, 14. 14 plus 14 is 28. Similarly, the second row, 3 plus 11 plus 14, 28. 28 plus 28, 56 after applying the apply function. Again, the row-wise sum of the third row is 5 plus 12 plus 15, 17 plus 15, that is 32. Here also 5 plus 12 plus 15, 32. So 32 and 32, as we sum up, it is 64. This is the result of applying the apply function. Hope you understood the concept of arrays. Thank you.